In this video, we're going to talk about the product rule. And so by the product rule, we mean we want to figure out how do we take the derivative of f times g. Well, f and g are two functions. Now this does not equal f prime times g prime, which is kind of the first thing that you might think, because the derivative of a sum of two things was the sum of the derivatives, and the same was true for the difference. But this is not true for the product. And a simple example of why is if we take the derivative of x squared, we know from the power rule that this equals 2x. But now we can write x squared as x times x. And so if we did the derivative of x times the derivative of x, we'd get 1 times 1, which equals 1, and that is not 2 times x. And so just from this one example, we see that in this specific case, this idea of f g prime being equal to f prime times g prime is not true. And so the way we're going to get the correct formula is we're going to do the following. We're going to let u be equal to f of x and v equal to g of x. So u and v are just representing the quantities of f of x and g of x. Then u times v is the area of a rectangle with length u and width v. So to see what we're saying here, we just have this rectangle, and it has a length of u and a width of v. So now what we're going to do is we want the derivative of f times g, so we're going to consider what happens if this value of x changes. So if the value of x changes by some amount delta x, then u and v change. So in other words, we're going to have a slightly different rectangle if we change the value of x a little bit. And to consider how u and v change, well, u, the change in u, which is delta u, will be f of x plus delta x. So that's our new point minus our old point. And delta v will be g of x plus delta x minus g of x. So in each of these cases, we're taking the new value of u minus the old value. So let's actually write that down. So this is the new value of u minus the old value. And that's true in both of these. And so what we've got here then is these are just the change in u and v. And now if we think about our picture, we're going to have a new rectangle. And now the length of this rectangle is going to be u plus delta u. It's going to be the amount that it was at plus how much it changed, and then v plus delta v. And so this is our new rectangle, but we can break it up into pieces based on what we had before. And so if this was our original value u and this was our original value v, then this big area was u times v, so that's what we had before. This is then delta u, delta v, and then... So now we have this rectangle u times v, but let's label the other pieces as well. So we're going to have v times delta u up here, delta u, delta v here, and then we're going to have u delta v in this piece. And so the whole change in the area is going to be just the pieces that we changed by. And so our change in the area in u times v is just going to be this piece, and this piece, because that's how our area changed. And so it's going to be v delta u plus u delta v plus delta u delta v. And now we're trying to figure out how u times v changed because, again, we want the derivative, which is a rate of change. And so to get a rate of change, we need to divide by delta x. And so we have delta u times v divided by delta x is equal to v delta u divided by delta x plus u delta v divided by delta x plus delta u delta v divided by delta x. So we just divided everything by delta x, and this is to give us a rate of change. So this is the rate of change in the area u times v with respect to x. And now, as you might recall, the instantaneous rate of change is the derivative, and that's obtained when we take the limit as our change in x goes to 0. So we want to take the limit as delta x goes to 0 of both sides. So just taking the limit of both sides as delta x goes to 0. Okay. So now on the left-hand side, that's just going to be the derivative of u times v. That's just the definition of the derivative of u times v with respect to x. Now we can break the right-hand side into pieces. And so we're going to have v times the limit as delta x goes to 0, because the value of v doesn't depend on the change in x, but delta u over delta v does. And then we have u plus, u times the limit as delta x goes to 0 of delta v divided by delta x. Again, we can pull the u out because u is just a fixed quantity. It's what we were at before we changed it all. And so it doesn't depend on delta x. And then we're going to have the limit as delta x goes to 0 of delta u delta v over delta x. So now, much as we did on the left-hand side, these becomes derivatives. So this is the derivative of u with respect to x. This is the derivative of v with respect to x. Then we have what's happening here. And so we have to consider what is happening in that limit. Well, the first piece is going to go to delta v over delta x, but delta u is just going to go to 0. Because as we make delta x get really, really small, u is basically not changing by any amount. And so this whole thing becomes 0 times delta v over delta x, which is 0. Because remember, we can split up a limit as a product of two things. And so what we found, then, is that we have d of uv over dx, the derivative of u times v with respect to x, equals v times the derivative of u with respect to x, plus u times the derivative of v with respect to x. And this, if we change it back to being in terms of f and g, is going to be our product rule. And so we have the following result. This is called the product rule. So what we just found is that if f and g are differentiable, they have to be differentiable to make sure those limits actually exist that we just did. And then we have that the derivative with respect to x of u times v, but u was f of x and v was g of x, is equal to v, which is g of x, times the derivative of u, which is f prime of x, plus u is f of x, times dv over dx, the derivative of v, which was g prime of x. And so this then gives us that the derivative of f times g is f prime times g plus f times g prime. And so we were able to compute the actual way that we take the derivative of a product of two things. So we've all done this very symbolically. So now let's actually do it with some functions applying this rule. So we want to take the derivative of x squared times e to the x. So if we want the derivative of x squared times e to the x, using our formula we just found, it's going to be the derivative of the first function, which is x squared, times e to the x, plus x squared times the derivative of e to the x. Now we know the derivative of x squared by the power rule is 2x, so we get 2x e to the x plus x squared, and the derivative of e to the x is e to the x. And so that then is our derivative of x squared times e to the x. And so we just take the derivative of the first function times the second, plus the first times the derivative of the second. So if we look at another example, we want to differentiate f of t equals the square root of t times 3 plus 2t. Now there are two ways of doing this derivative. We could multiply it out and then take the derivative, or we could use the product rule. We're going to use the product rule since we want to practice with it. And so we have f prime of t. It's going to be the derivative of the first function. So the derivative of the square root of t times the second function plus the first function, which is the square root of t, times the derivative of the second function, which is 3 plus 2t. Now, remember that the square root of t is t to the 1/2. And so the derivative of the square root of t is 1/2 t to the minus 1/2. Then we're going to multiply that by 3 plus 2t. And then plus the square root of t times the derivative of 3 plus 2t will just be 2, using the power rule because the derivative of 3 is 0, and the derivative of 2t is 2. So now multiplying this out, we're going to have 3/2 t to the minus 1/2, plus, we have 1/2 times 2, which is 1, then t to the minus 1/2 times t is t to the 1/2, plus 2, then square root of t is t to the 1/2. So in the end, we get 3t to the 1/2 plus 3/2 t to the minus 1/2. And so that then is our derivative in that case. So now we're going to look at one final example, which we're going to do in a very symbolic setting. You sometimes will see questions like this. They're primarily written in exams in college class, Calculus 1 classes, just kind of to help you really see, do you know what the product rule says. So we're going to suppose h of x equals f of x times g of x, where f of 4 is 2, f prime of 4 is minus 1, g of 4 is 3, and g prime of 4 is 2. So now by the product rule, we know the derivative of h is equal to the derivative of f times g plus f times the derivative of g. And so if we want, I didn't say this, but we want to find h prime of 4. And so we know the derivative of h prime of x is f prime of x times g of x plus f of x times g prime of x. So now we're just going to plug stuff in. We know that h prime of 4 will be f prime of 4 times g of 4 plus f of 4 times g prime of 4. Now we just plug things in. F prime of 4 is negative 1, g of 4 is 3, plus f of 4 is 2, and g prime of 4 is also 2, and so we end up with negative 3 plus 4, which is 1. So h prime of 4 is 1. And so, like I said, this is more just, do you actually know the product rule? But you see questions like this sometimes in calculus classes. So I just wanted to do an example of one such question.